I'm Yonghun Jung. So I'm a current graduate assistant at the IDM Lab from NYU. So today I'm going to cover how to create uninspected beauty with using motion capture data in virtual space. So this is today's my presentation overview. So first I'm going to give you guys really short introductions and then just talk a little bit about the concept of unpredictability, because I usually work with this concept while I'm making my work. So, and then I'm going to show a demo on how to create my work, kind of a step by step. And then below information are the key points that I'm going to cover in my demo. So this is me. So yeah, so before I get started, I kind of wanted to briefly talk about myself and how I ended up working with the unpredictability of human motions. So before I came to NYU, I studied fine art, but now I'm just focusing more on virtual productions. And then, as I said before, I'm current graduate assistant at the Excel Lab in the Integrated Design and Media program. So surprisingly, in my undergrad, I majored in ceramics. So at the time, I was really interested working with the kiln, because all of my work just came out differently depending on the air circulation, so fire temperatures inside of the kiln. So, but I kind of enjoy this unexpected kind of beauty. So this unexpected, my interest kind of led me to look at generative art. And then the basic meaning of generative art is that it's an art created using autonomous system in whole or in parts. So I kind of really attracted to this randomized aesthetics, and then the aesthetics I'm still pursuing is kind of extension of this generative art. And then I believe many of you guys might ever heard of a generative program such as processing or a P5.js. But I mean, then you guys can realize that those kind of a function of the randomness inside of those generative art programs are not really fully random, but somewhat kind of give us constant motions. But I just wanted to create more dynamic, kind of expecting more kind of unexpectedness. That's why I was kind of introduced to the concept of unpredictability. So this concept is not really complicated. It's just allowing external element to create more unexpected outcomes. And for me, this external element is using a human body motion. So this quote is one of my most favorite quote from Alexander Asanovics. And then I just like to share this quote with you guys. So in new method of supporting creativity, computers should be used for creation of less precise, unpredictable, but more inspiring images. Intuition, unpredictability, and no logic are the essence of creativity in the selection of associations. So before I start working, I just usually keep this quote in my mind. And then I think that's why these two programs, which are Houdini and then Niagara, really fit to my concept. So I was just gonna briefly explain these two softwares in my own opinions. So first, Niagara system is module-based visual programming. So by stacking multiple module together, and then just tweaking some of the parameter values inside of them, we can just create incredibly diverse range of visual effect within the open world. And of course, Unreal Engine, the program itself has really fast rendering with outstanding quality. So Houdini is best known for node-based workflow, and then this workflow makes it possible to create complex particle system, such as natural simulations and then abstract geometries. So if we can just use these two programs together, then it's then it's like synergy effect is gonna be enormous, because if I use like a nature simulation data from Houdini to Niagara, and then just like use like Unreal Engine's like rendering capabilities, then I can like really quickly build multiple layers of the particle system at one time. So before I kind of like start my demo, I like to show like my previous work. That's like what kind of aesthetic that I'm pursuing now. Oh yeah, so like the human motion is the one that I got from my school. So like our school has like a second biggest motion capture studio in New York City. And then like the effect that I kind of like just created is like using like Houdini and the Niagara effects together. So I will gonna start like first of my demos is like how to animate like a 3D avatars. Yeah, so I'm currently using like a Ready Player Me, but you can just like use any other software such as like Make a Human. But it kind of works out for me because it kind of give me some kind of like a stylish avatar in my personal opinions. So like you can change like kind of your facial like a shape, and then just put your clothes on there. You can choose your clothes. But since I already have one, I'm going to use my own characters. I mean, because someone it looks like me. So yeah, so I will just like use this avatar. So whenever we export from Ready Player Me, it's gonna be GLB, but we have to we have to convert it to FBX, and then just give it the skeleton. That's why I'm using like a Blender for that. And then if you just go to the import, there's gonna be GLB file import. And then if you guys wanted to see like a full like the materials, on the top right corner there's like a viewport shading. So if you click it, then you can see like all the textures. And then there's like since we have like all the skeleton and the texture, we can just like export to FBX. And then here later, there's like some settings that I kind of wanted to like highlight. So like on our path, just make sure it's copy, because like we want to keep like all the materials with us. And then just like under geometries, like a smoothing shape is gonna be like a face, and then just uncheck apply modifiers, and then add lip bones, and then like a bake animations, and then export like FBX file. So before you do anything with the avatar, it's necessary to add like a T-pose. So for that, we'll do it at the Mixamo. So you can just like upload your characters that you just created. So for adding T-pose, you have to go to the animation, and then there's like a search. All you have to do is just like type T-pose. Then you're gonna be shown in the first place. So for exporting, you can just like export a file as it is now. So the current version of the Unreal Engine that I'm using is like Unreal Engine 5. And then this is the default of like Unreal Engine 5. So for importing, I'm just gonna create like an individual folder to import my avatar. So before you export anything, just like I think I always click reset to default first, and then just trying to add something that like really necessary to my work. Now it's like there's like all the metrics kind of like imported into like Unreal Engine 5, and then there's like a T-pose in our scene. But I was just gonna give like a more animation at the like a mixamo. So the animation I want is kind of like a more energetic, because like later I just like want to show you guys, introduce you guys why the kind of strengths of like a Niagara system with this like motion. And I'm gonna do salsa dancing. And then for this like skin is like just export as like without skin. Put that down. Yeah, so since we're going to use like the same T-pose, so for the skeleton, just like select my avatar like T-pose. This is the first T-pose that I imported. Then if you just like drag the animation file to this scene, and then just like rotate to face my directions. There's gonna be the T-pose and the salsa dancing animation. So next is like we're just gonna briefly build like a simple lighting system and then like a level design in Unreal Engine. So this is the like abstract of geometry that I created, and then I'm going to use like this one for our demo today. So for this one, I just use like connected adjacent pieces. So this is a kind of like the simple 3D object, and then I just like use connected adjacent pieces, and then use like VDB smooth SDF, like the Gaussian type. So this shape, this simple like a platonic shape, and then torus is gonna be for my Niagara system. So like a layer, please export this file as like FPPX. So before we start anything, just like start new and then just create like an empty level. And then make sure you just kind of like save it under the like our map folder. So now I will now just kind of build like a really simple lighting. I'm currently using like a rectangle light, but for this rectangle light, you can use like directional light. But for me, this rectangle light is always like working better. And then let's just like tweak some of the parameter values to shine on the like our like, entire level. So for the intensity for the rectal lights, usually we need like a really high number. It's like 1500. It's kind of like, for me, it's like 1500 is like the average number to use. And then I will just use like a lightness or importance of volume. So like this one is allowed to concentrate only on the area that needs like detailed indirect lighting. And then I will just add like a spear reflection capture to intensify the reflection on the surfaces of like object. Then I will just create like a individual folder for like my 3D geometry. So this abstract geometry is like more than 1 GB. So I mean, whenever you work with the Unreal Engine 5, it takes a really long time to load and then save the files. So please have some patience. So it is not like my computer is not working. It's working, but it's like it really gives me like a lot of time to just load the file. Okay. Yeah. So reset to default. And then for the color input, I'll just like change to replace. And then just like combine meshes just in case because the map is like really big. So I just like wanted to have like kind of like the meshes to be keep intact. So I will scale it up because like since I'm going to use this geometry as like my background, kind of like my background map. So for this one, I don't need to have like collisions. I mean, because like whenever since it has like the collisions, whenever I play my game, I mean, just like my Unreal engines, then it's like you were gonna disturb my camera like a movement. So for me, I just like delete. I just like, remove the collisions of this like object. And then of course just tweak the parameter values that it can shine on our like entire object. Then I'm just gonna give like a color, kind of like a cool color. So each light has like a really their like own color system, but I usually work with the temperatures because like it just gave us like less problem. And then there's kind of like this sudden change of the lighting system is because like Unreal Engine like automatically try to calculate the lighting source for us. So I'm using like a post processing, and then just type there like infinite, and then just like turn on like infinite instant. And then just check the first one. And then for the mean and the max value, just like type 1. And then this is the like a fixed lighting color. I mean, this is like the fixed lighting for our entire project. And then I'll just add like our platonic. So wait. So now I'm just gonna like make like individual folder so that I can just like kind of organize my outliner. Just say like lighting and then just volume. And then I will just create like a really simple like a cylinder because I just wanted to make like some kind of like a stage for my avatar to dance on. So now this is the what our like a map looks like. So now I think like this is like one of the most important demos in my presentation today, which is working with like a Houdini point cache data and then importing its file to Niagara system. So I created like a pyro solver which generates the smoke effect in order to get Houdini point cache data of like nature like simulations. So like you guys might not see very well now, but once we just go into the geometry, so for this one, I use like the pyro burst and then just give it a bit of like a noise. And then create like this kind of like explosion shape. So now we have to give a little bit of like particles to follow those kind of like simulations. So I made like a simple sphere, and then like scattering so scattering points to spawn like particles. So whenever you create it for the Niagara system, I just recommend you to spawn just like particle only at the like a first frame. And then the most important things here to make our particles follow our pyro solver shape through using the velocity. So please just kind of like keep this setting. Yes. So before we export our file through the lab Niagara, so make sure this object is typed as like a pop object, because like we just want it to have like only particle data, not like any other data. Then please like check your path. And then you're kind of like starting and then ending frame. And then make sure also like check the attributes too. And then you can just like, and then you can render. So for this one, now I'm just gonna bring our Houdini point cache data into Unreal Engine. So if you double click this, this is the all the attributes information that you guys just have like exported from Houdini. So usually, before we bring in this like Houdini file, we have to go to the edit, and then under the edit, there's like a plugin, and then please type like a Houdini. And then you guys have to download this Houdini Niagara in order to like import this like point cache file. So in order to find like a Houdini Niagara basic emitters, so you have to uncheck library only and click parents emitters. Then you're gonna see this Houdini Niagara basic. So this is the kind of default of like how Niagara system looks like. And here, like there's like there's like a three most important node is the spawn particle from Houdini point cache, and then sample spawn Houdini point cache, and then the sample Houdini point cache. So like you have to put your like point cache data into these three. And now you can see we are kind of like spawning Niagara particles using like a Houdini point cache data. So this like a max timing, this value is like kind of like a frame rate that we just like exported from Houdini. So if you just like copy and paste here, then it is now playing at the same frame rate as we see in the Houdini. So rather than use like a sprite rendering, we'll just change to mesh renderer, because mesh renderer has like, I believe it has like a better emissive like materials. So later I'm gonna change this sphere to our like a platonic solid, but for now I will just keep it as like a sphere, and then I'm going to show you guys like how to create really simple emissive materials. So in order to change the particle color inside of the Niagara system, it's like we have to use like a particle color and then connect this to our base color. And then I would just like use multiplier. So like later you can just like increase the density of like brightness. And then I would just promote our density value. And then I will just create like a material instance because like we are going to use like this material over time. And then if you change like your density to, I guess like 5, then you can see it's getting bright. So now let's just change the value of our like mesh size on the like initialize particle. So since we're not using sprite renderer, please make sure you guys like uncheck the sprite size or like check the mesh scale. And then I will just give it a little bit of a force, like a mesh rotation force, to make like my particles spin more. And of course, just add more color. So and then here I'll just like usually add like a scale mesh size. So it is like based on kind of like graph. So we can just like make it like a smoothly like a fading out. And then please save this Niagara system. And if you just like drag this Niagara system to the scene, and then this is like how we created our first like Houdini Niagara effects in Unreal Engine. So this is gonna be like my last demo. So I mean, since we already made like a Houdini Niagara effects, and then we're just gonna like combine everything with the like using like motion capture data. And then I will just like first our animation file to the scene. So I'm going to make this animation more like dynamic using like Niagara systems. Since like this process takes a lot of time, it's a little bit complicated. I have already built like a blueprints and then like a Niagara system for this. So if you just click the first like static avatar effect, so as you can see here, like I already replaced its original texture with particles. So here there's like two important nodes, which are the like initialize mesh reproduction sprite and then update mesh reproduction sprite. Because like this is like where we're gonna put our T-pose and animation in it. And then I have changed my rendering system from CPU to GPU because I'm currently spawning like 1000 particles like every 2 seconds. So if you just go to our second particle system, so I just like added this system because I want to introduce guys kind of great thing about like using the motion capture in Niagara system. Because like there already like a physics like kind of like system built in. So like whenever avatars kind of move more, its velocity will be added to our like a force. So I mean, unfortunately, like we cannot like put animation file directly into the Niagara system. So like we have to like promote this mesh value, and then just like put the animation and then T-pose from the outside. So I just make the user like expose like the skeleton mesh. And then please make sure you replace it with our like exposed mesh skeleton too. So if you please like drag these two Niagara system to the scene, and then if you kind of click one of the Niagara system and kind of like scroll down, you guys are gonna find our like a mesh data, skeleton like mesh data. So here you can just put your avatar and then put the animation into source. And then you can see it's being successfully playing on top of our like avatar. And then we're gonna do the same thing to our like other Niagara system. So what am I doing now is like I just wanted to hide my like a salsa dancing like a textures, but only wanted to show my particle system. So if you see the motion of the avatar velocity has been added to our like a particle system force. So the more our particle, more the avatar moves, the more the velocity we're gonna be added. And then I was just going to just put it just like one blueprint. And the same as before, just like the add like skeleton mesh, and put your animation and then T-pose, and make sure you guys type the visible, turn up the visible, and make sure you guys click the always T-pose and then refresh button. And then add like a two Niagara system that we created. So we're going to erase these two Niagara system and then drag our blueprint. Once we click the play button, it's gonna be do the same thing, but it's gonna be put in just like one blueprint. So now I'm going to spawn like our Houdini like a Niagara particles from those kind of like floating particles. So the reason why I decreased like a spawn count is like spawning too much like Houdini point cache data, you're gonna hurt your like computer's like spec. So I just like, and then I'm just like exporting. I'm just kind of sending the particle position data and then normalized age data to the blueprint. So I have already made my visual scripting, and this is where like all the data of the exported particles are saved. So here you guys might see the name size, but in our case, it is just receiving our like normalized age data. So you guys do not have to worry too much about the name. So normalized age data, normalized age is the value should be from 0 to 1. So I just cramp it and then make sure it doesn't go over like a 1. And then it is basically saying whenever our floating particles die, we're gonna spawn our Houdini point cache data. And then I'll just give it like a random position of the rotation, random numbers for our rotations. So as you can see, like when those like floating particles die, you're gonna spawn our Houdini point cache data. So, but I will just give it more like kind of like interesting look. So like this time, I will like spawn my custom Niagara system from the like a Houdini Niagara system. So kind of like the same as our previous Niagara system, we're gonna add like a export like a particle data in like updates and then send its data to blueprints. But this time I'm gonna send like a Houdini position data, but normalized age data we're gonna be the same. So if you open the blueprint, so for this time, I'm not going to use like every particles, but only kind of like a first particles of our Houdini Niagara system. So I mean, it really depends on your like, computer like specs, but too many particles really cause a lot of problems. So I'm just like spawning like only one particles. And then there's like array index. It's like So I use like equal node and just saying spawn only one first particles. And then this like a size, this like normalized age value is gonna be same as like a previous Niagara system. So if I just connect this node to true, then you're gonna once Houdini Niagara system dies, you're gonna spawn like my own kind of custom Niagara system. And this is what it looks like. Yeah, and then accidentally I just put the mean value as like 360. So just change to 0 and the max value to like 360. So if you play now, once those floating points dies, you're gonna create like a Houdini point cache. And then when those Houdini point cache dies, you're gonna create like my custom Niagara system. So I'm going to show you guys like my kind of like recent work that I kind of like. So thank you so much. And then if you have any other question, please send me an email.
Does anybody have any questions? Anyone? Yes. Oh, I'm sorry. Excuse me. Let me sneak through here. No problem. Yes, question? Yeah.
Was there a reason to not do more of the particle work in Houdini and just feed a more denser particle system and taking all the anim in Houdini and just using Unreal as like the final assembly of the particles?
Yeah, so I mean, because like Unreal Engine, because Unreal Engine is like really fast like rendering like a system, that's why I just like make kind of like complex particle system in Houdini and then just like export those file and then just like add more particles in Unreal Engine so I can just like kind of like see constantly kind of like changing of the my particle effects.
Awesome. I saw another hand, I think. So, right here? Yeah, for sure.
Thank you. Thank you again. Can I watch the same reel at, in your website or YouTube, whatever?
So I didn't update this yet, but I mean, because like for this one, I'm still working on it. It's not like completed work. So, well, I mean, if I finish it, then I think I'm just gonna upload it later to my website.
Okay. All right. Thanks.
Thanks.
Anyone else? Other questions? All right, excellent. Let's have another round of applause.